Hello, I like to explain the rotational equilibrium experiment. Before we do that, I like to actually um, go over a magic trick so that you can learn the center of gravity and also be able to perform a magic trick for people around you. So here I got the website. Um, if you hold a ruler, doesn't matter how long it is. As a matter of fact, it doesn't even have to be a ruler. It could be a pen, a pencil, irregular shaped objects like a pair of scissors. Of course, if it's a ruler, you can also perform this. So put the ruler on your hand as shown in the picture. Start from both ends. So you can just start them on the end, just place them on your finger. Exact location doesn't matter. And then you push the two hands towards each other. Okay, just move slowly. Every time, doesn't matter how you start, you always end it with both hands or both fingers at the center of the gravity. So this is how we can find out the center of gravity of any object we can place on our hands. So this is a magic trick. It's a center of gravity magic trick. All right. After that, I'll introduce the experiment, the rotational equilibrium. The rotational equilibrium experiment let us study leverage. So leverage means you can use a small weight to counter a much bigger weight. That actually means in real world, that means you can use a small weight to move something a lot heavier than it by using the distance change. So specifically, I want to start with the ruler. So the first part we do is we find the center of gravity of a ruler. So we tie the ruler at the end of a string that you have. Well, then you move the string slightly. Eventually, you're going to find a equilibrium state. That is, the ruler will stay at rest, balanced at the end of the string. Okay, next, this time I like you to pull out your little car because everybody has a unique car. I like your car to be in your picture. Interestingly, in the center of this ruler, we have this little thing that can hold objects on top. So I like you to find two small objects of different weight. I mean, usually they are of different weight, and observe the different weights and the different location of this. So you're going to solve this lab by making two measurements. The first measurement is the mass of each object. If you know the mass, then you know how to convert them from grams to kilograms and from kilograms to newtons. You can convert them to weight. Once you have the weight, you can calculate the torque. Okay, so in this experiment, because first we found the center of gravity, we tied the rope where the center of gravity is. So when we are able to balance two objects on both sides of the ruler, there are two torques. One torque is caused by the object on the left. The other torque is caused by the object on the right. So each torque equals to the weight multiplied by the distance from the center of this object to where the string ties the roller. So on one side is the weight multiplied by the distance to the string. The other side is the weight multiplied by the distance to the string. Okay, so these two torques are balanced, okay, because it's in the equilibrium state. These two torques are balanced. So that means the heavier weight is at the shorter distance and the lighter weight is at a bigger distance. So this is what we call leverage. We can use a lighter weight to move a heavy weight just by having a longer handle. So this is how a lot of tools are made. It's called leverage. In this lab, we perform this rotational equilibrium experiment. So in this particular state, it's a rotational equilibrium. And leverage is a very useful way to solve a lot of real world problems.